Hello, my dear students and the rest of the learners. Welcome to part 16 of the 7-part series of tutorials in computer structured programming in C and Pascal. This is section 2 of 3 in the topic Control Structures. My name is JM, or you can simply call me EMELISWAP. In this tutorial, I'm going to look at selection control structures in C and in Pascal. I'll therefore begin with introduction to selection control structures, and then we shall look at the if-then control structure that we also call the simple if statement. And to demonstrate on this structure, I'm going to show you an example of a pseudocode, a flowchart, and sample program in C and Pascal. I'll then look at the if-then-else control structure that we also call the if-else in C. And I am going to show you a pseudocode, a flowchart, and a program in C and Pascal implementing this structure. We shall then look at the nested if that we also call the nested if-else structure. And I'll demonstrate how we apply it using a pseudocode, a flowchart, and a program in C and Pascal. I'll then look at the case structure, which we also call switch in C, and I am going to demonstrate how we use it with the use of a pseudocode, a flowchart, and a program in C and Pascal. We begin with the introduction to selection control structures. A selection control structure is a structure whereby an action is taken depending on a condition that has been met. Therefore, execution of statements depends on a condition that runs either true or false. Therefore, it is used in situations whereby a certain action is supposed to be taken depending on the condition that has been met. Selection means that a program control may be transferred from one sequence to another sequence of instructions depending on a condition. In selection structure, a question is asked, and depending on the answer that is gotten, the program takes one of the two courses of action, after which the program moves on to the next event. So generally, in selection control structures, an action is taken depending on whether the condition has evaluated to true or if it has evaluated to false. When a situation evaluates to true, a certain action is taken. When it evaluates to false, a certain action is also taken, or one of the actions are not taken based on the condition that has been met and what is supposed to be done based on the condition that has been met. Selection structure has 2 points of exit for flow or for program flow. Therefore, selection is a control structure in which a number of processing options are represented and an option is chosen for execution depending on a condition that returns true or false. Selection forms part of the decision-making facilities within programming languages. They allow alternative actions to be taken according to the conditions that exist at a particular stage in a program execution. The 4 main types of selection control structures used in most high-level programming languages are the if-then structure, that is the if statement or simple if. Then we have if, then, else structure, or simply the if-else statement. We have the nested if, or what we call nested if-else structure. Then we have the case structure that is also called switch statement, especially in C. Let's look at the if-then structure, or the simple if, the if selection structure. This is a structure which is used in a situation whereby only one condition needs to be met for an action to be taken. Otherwise, nothing else is done. It is used if only one option is available. All other options are ignored. Its general syntax or format is as follows. In Pascal, we write it as if condition, then execute the following statements, and then and if. In C, we write it as if condition, execute the following statements, and then and. My dear students and the rest of the learners, remember we said that in C, everything is in lowercase. And therefore, I would like you to see or compare between the way we write it in Pascal and in C. In C, we don't have then, nor do we write and if. So we make use of braces. The left brace and the right brace to indicate the and. So instead of the one and if, we have the right brace. The flowchart extract for this structure is as follows. If a condition evaluates to true, execute the statements and exit. Otherwise, if the condition is not met, if the condition is false, just stop execution, exit. So from this flowchart, my dear students and the rest of the learners, you can see that a certain set of instructions are executed only if the condition evaluates to true. Otherwise, nothing is done. Remember the symbols that we used for flowcharts and what we said in my previous presentations in this series. So the statements part of the structure will be executed if and only if the condition is true. If the condition is false, the statements part of the structure will be ignored. The statement itself can be simple or structured, though it's often a compound statement. If you don't remember what we said or what is a compound statement and the simple statements, kindly ensure you go through my previous presentations in the previous parts in this series of tutorials in structured computer programming or in computer structured programming. The following is an example of the if-then control structure in terms of a pseudocode, a flowchart, and sample programs. An example is develop a pseudocode, a flowchart, and a sample program that calculates the area of a circle only if its radius is greater than 5. The pseudocode will read as follows. Begin. Set the pi to 3.143. Then print or display the message. Enter the radius of the circle on the screen. Then read radius. Allow the user to enter a value for radius. Once the radius is entered, check. If the value entered is greater than 5, then calculate the area of the circle by multiplying what has been entered as radius by itself and by or with what is in the memory location called pi. And the overall results, store them or assign them in the memory location called area. Then print on display the area, display the area or the content of memory location called area. And then end the condition and end the program. So my dear students and the rest of the learners, this pseudocode illustrates very clearly to you that this program will only calculate the area of the circle if the radius entered or the value entered is more than 5. Otherwise, nothing will be done. If anything is entered which is less than 5, there will be no computation or calculation of the area. Let's now look at the flowchart. The flowchart looks as follows. Begin. Assign 3.143 to the memory location called pi. Read the value of radius. Check if the value of radius is greater than 5. If the value of radius is greater than 5, that is yes, calculate area. Multiply the value entered by itself and then by or with what is in the memory location called pi. And the overall results, assign them to the memory location called area. Then pick what is the memory location called area and display it on the screen. Print the area and end the program. Otherwise, if what has been entered is less than 5, then end the program. If what is entered is less than 5, end the program. Perform no calculations or computations. So my dear students and the rest of the learners, you can see the statement for area and the print area will only be executed if the value entered is more than 5. If the condition evaluates to true, to yes. So here is a sample program in Pascal. So program area circ. The comment is program that calculates areas of circles whose radius exceeds 5 centimeters or 5. Declare memory location called the pi, which is going to hold a value which will not be changing, which is constant. And then assign 3.143 into 8. Then declare two memory locations, one called the area, another one called radius, that will hold data of type real or data that will have some fractional part. And the content is expected to be changing. So variables, variable or var, radius, area, type real. Begin. Display the message. Enter the radius of the circle on the screen. So write this message on the screen. Enter the radius of the circle. And once that statement is displayed, move to the next line. Then in the next line or below that statement, get or read the value that is going to be entered by the user as radius. So that value, store it in the memory location called radius. And then move on to the next line on the screen. So next is check if the value that has been entered, if the value in the memory location called radius, if the value in the memory location called radius is more than 5, is greater than 5, then do the following. Calculate area. So get what is the memory location called radius, multiply by itself, then multiply the answer with the content of memory location called the pi. The overall result, store it or assign it in the memory location called area. Then write the following on the screen. The area of the circle is, pick what is the memory location called area, display it in the screen or on the screen, formatted as follows. it should be maximum of 6 characters, but 2 of those characters should be reserved for the fractional part. So display the statement, the area of the circle is whatever is in the memory location called the area, but the fractional part or the decimal point should not be more than 2 digits. So if, for example, what's the memory location called area is 50.52, then the statement will read as follows. The area of the circle is 50.52. Then drop next line, 1 line. That's what right line means. Then end the calculation and end the program. What about in C? So this is how we write our comment in C. Our comment is program that calculates area of the circle whose radius exceeds 5. And then we include that file. We include the preprocessor directive. The preprocessor directive hash include stdion.h, standard input, output, header file. Then void main. We have our left brace there. Then our declaration and initialization statement for pi. And then we declare 2 memory locations, one called area, the one called radius of type double. Then we display the message on the screen, enter the radius of the circle, and we drop 1 line. Then read what has been entered by the user, the value entered, which is of type double. Read that value and store it in the memory location called radius. Remember, %LF, that the whole of that is identifier for double data type, double. So simply, we are reading a value that has fractional part, and that value will be stored in the memory location called radius. Then check if the content of a memory location called radius is greater than 5. Calculate area by multiplying the content of radius with itself and then multiplying it with the content of memory location called the pi, and the overall result, assign it to the memory location called area. Then print the following statement on the screen. Print if the area of the circle is, pick what is the memory location called area, format it in 6 characters with the 2 of them being reserved for the fractional part. So the area of the circle is, for example, 99.62. The area of the circle is 99.62. And drop the next line. Or drop the next line. And then end the computation and the check. And end the program. That's the purpose of that brace, the writing brace. Let's now move on to the if-then-else structure or the if-else statement. This is a structure which is used in a situation whereby there are 2 available options to be taken. One if a condition is met, and the other if the condition is not met. So in this control structure, a certain set of statements will be executed regardless of whether the condition evaluates to true or false. So one of them will be picked, but not both. It is either when condition evaluates to true or when the condition evaluates to false. So the if-then-else construct contains 2 parts, the then part and the else part. The condition is tested before an action can be undertaken. If the condition shows true, then the then action is taken. Otherwise, the else action is taken if the condition is false. Simply, my dear students and the rest of the learners, this control structure allows a set of instructions to be carried out at a certain given time. Either when the condition is true or when the condition is false, but not both. It can't execute the statements when the condition is false and also execute statements or instructions when the condition is true. It's only either one of them. When the condition is true, something is done. When the condition is false, nothing is done. Or something is done when the condition is false, and nothing is done when the condition is true. Something is done when the condition is true, or nothing is done if the condition is false. So either way, some actions will be taken. So its general syntax or general format is as follows. In Pascal is if a certain condition is met, then execute statement 1. Otherwise, or in other words, if the condition evaluates to false, then execute statement 2. And then we add the execution. So if a condition is true, do the following: execute statement 1. Otherwise, if that condition is not true, meaning it is false, execute statement 2, and then you end. In C, we write it as follows. If condition, the opening brace or left brace, statement 1, closing brace or right brace, else we have the left brace, statement 2, right brace. Now, the only difference between C and Pascal is in terms of the syntax. Just as I have said in the previous structure, we don't use the terms then in C, nor do we have and if. We have only the braces. So we write it as you can see. If condition then, you can see how we write it. Statement 1, everything is in small letters, lowercase. Else, we have else in lowercase. Then statement 2, and then and if, you can see how we do it. So it's good for you, my dear students, and the rest of the learners to see the difference. And if you have listened to my previous parts in this series of presentations, this is very clear. So its flowchart extract, whether in C or in Pascal, is as follows. Remember, pseudocode is not restricted to any language, and flowchart is not restricted to any language. So if condition evaluates to true, execute statement 1 and then exit. Otherwise, if the condition evaluates to false, execute statement 2 and exit. So at any given time, either statement 1 or statement 2 will be executed. So when the statement is executed, the condition's expression is evaluated. If the result of the evaluation is true, then statement 1 will be executed. Otherwise, statement 2, that is, when the statement evaluates to false, statement 2 will be executed. After either statement 1 or statement 2 has been executed, the statement following and if is executed. In other words, after the section for the structure, control structure is over, the next subsequent statement in the source code is executed. One statement or the other is always executed, but never both statements. C programming language provides the conditional operator. That conditional operator, we call it the conditional operator, which is closely related to the if-else statement. The conditional operator is C's only ternary operator. That is, it takes 3 operands. The operands together with the conditional operator form a conditional expression. The first operand is a condition. The second operand is the value of the entire condition expression if the condition is true, and the that operand is the value for the entire conditional expression if the condition is false. For example, printf display the content of the memory that has been declared as a string and drop one line. Then is grade greater than or equals 60? If yes, display the message passed. Otherwise, display the message failed. Printf or display the following. Pick what is the memory location called whatever or called whatever that is of type string. Then check what is the memory location called in grade. Is it greater than or equals to 60? If yes, display the message passed. If not, display the message failed. This statement contains a conditional expression that evaluates to the string literal passed if the conditional grade greater than or equal to 60 is true, and evaluates to the string literal failed if the condition is false. So that's what this statement does. It contains a conditional expression that evaluates to the string literal called passed if the condition grade is greater than or equal to 60 is true, and evaluates the string literal failed if the condition is false. In other words, the conditional expression will evaluate to passed if the condition grade is greater than or equal to 60 is met. Otherwise, if that condition is not met, meaning it is false, then it will evaluate to the string literal failed and display it on the screen. The following is an example of an if-then-else selection control structure using a pseudocode, a flowchart, and a sample program that accepts a radius for a circle and then calculates the area if the radius is greater than 5 or a perimeter if it's less than 5. Then it displays either the perimeter or the area based on the radius entered. So we have the pseudocode. Begin, set pi to 3.143, print, enter the radius of the circle, input radius. If radius is greater than 5 centimeters, then calculate the area by multiplying the content of pi times the content of radius times the content of radius. Output area, display area. Otherwise, if the value entered as radius is less than 5, then calculate perimeter by multiplying the content of memory location called pi with the content of a memory location called radius multiplied by 2. So the result, assign it the memory location called perimeter. Then display the results in the memory location called perimeter on the screen. So display or output perimeter, and then you end the program. So that's a pseudocode. So if the radius is greater than 5, area will be computed and displayed on the screen. Otherwise, if the value that is entered is less than 5, meaning the condition is false, calculate perimeter and display the results on the screen. Let's now look at the flowchart. That's the flowchart. So begin, assign 3.143 to the memory location called pi. Read the value of radius, input radius. Check if radius is greater than 5. If radius is greater than 5, that means that is true, that what has been entered is greater than 5. Then calculate area. That is, multiply the content of radius by itself and with the content of the memory location called the pi. The overall result, assign them into the memory location called the area. Then pick what's the memory location called the area and display it on the screen. Output area. Otherwise, if radius is less than 5, that means is radius greater than 5? No. False. Calculate perimeter by multiplying the content of radius times the content of pi times 2. And the result, assign it to the memory location called perimeter. Then pick what is the memory location called perimeter and display it on the screen. Output perimeter. End the program. So whatever value that is entered, whether it is less than 5 or more than 5, something will be done. If it is greater than 5, the condition will evaluate to true, area will be computed, and results get displayed on the screen. If the value entered is less than 5, meaning radius is not greater than 5, then perimeter will be computed, and the results will be displayed on the screen. And that's the end of that condition. How do we write that in Pascal? So yes, as some program in Pascal, the program calculates either area or perimeter based on the radius entered. My program is called area peri. Const pi equals 3.143. Two memory locations or three variables are declared. So I'm declaring three variables, three memory locations whose content will be changing during program execution, and they're going to hold data which has fraction of part or real. So this is a declaration statement for memory locations, the following memory locations: radius, area, and perimeter. They are going to hold data of type real. That means data with a fraction of part, and they are variables. The content in them will be changing. Begin. Display the following statement. Right line, enter the radius of the circle. This statement will be displayed on the screen. Then read radius, read line radius. So read the value entered and store it in the memory location called radius and drop one line. Then check. Is the radius entered greater than 5? If radius entered is greater than 5, or if the content of the memory location called radius is greater than 5, then do the following. Calculate, pick the content of memory location called radius, multiply by itself, multiply it with the pi, and the overall result, assign it to the memory location called area. Then display the following or write the following on the screen. Right line. The area of this circle is, pick what the memory location called area, format it into 6 characters, and assign 2 of them to the fractional part. That means the decimal fraction or the fractional part should not exceed 2 digits or 2 characters. Then you add. Otherwise, if what has been entered is less than 5, what is the memory location called radius is less than 5, then begin. Perimeter, or pick what's the memory location called radius, multiply by the content of a memory location called pi, multiply it by 2. The overall result, assign it to the memory location called perimeter. Then pick what's the memory location called perimeter and display it on the screen, accompanied by the following message. So right line, the perimeter of this circle is, what is the memory location called perimeter? Format it into 5 characters, with the 2 of them being reserved for the decimal fraction. So the output will look as follows. The perimeter of this circle is, for example, 90.42. The perimeter of this circle is 90.42. The answer will depend with the radius entered by the user. Then you end, and you end the program. What about in C? That's the comment, calculates area or perimeter based on the radius entered. So this program is similar to the one which I have demonstrated for Pascal. So include the preprocessor directive for standard input output and a file, because you are going to make use of the input and the output devices. Then void main is the main function for the body of the program. Declare and initialize memory location called pi with 3.142. So const double pi equals 3.142. Then set 3 memory locations assigned, declare 3 memory locations, one called radius, area, and perimeter, they are of type double. My dear students and the rest of the learners, this program is similar to the one I have already demonstrated in Pascal. The only difference is the syntax, how we write it in C. So read radius, check if radius is greater than 5. If it is, compute area as follows. Display the perimeter, display the area of the circle. Pick what's the memory location called the area, which is of type double, That is what percentage F in this statement means. And display it next to the statement or after the statement. The area of this circle is. Then end that part. Otherwise, if the value entered or if the content of memory location code radius is less than 5, calculate perimeter as follows. Display the statement. The perimeter of this circle is, pick what is the memory location code perimeter, format it into 5 characters with 2 of them being reserved for the decimal point, and display that value on the screen. And you end the program or the main function. Let's move on to the third structure, which is nested if structure. This is a structure which is used in a situation where there are many available options to be taken or to be considered, and only a single action is taken depending on the condition that has been met. My dear students and the rest of the learners, the difference between nested if and the if then else is simply the if then else structure had 2 sets of alternatives, with one of them being executed regardless of what happens. So if the condition evaluated to false, something is done. If it evaluated to true, something was done. So there are only 2 alternatives to be taken, either the true alternative or the false alternative. But for nested if, we have several alternatives to be taken, more than 2. So it's similar, almost similar to the if then else that we have looked at, but here we have now additional alternatives. So we have several alternatives to take, but it's only one alternative that will be executed based on the condition that will be met. So this structure is used in a situation where there are many available options to be taken or to be considered, but only a single action will be taken depending on the condition that has been met. So it's used where 2 or more options have to be considered to make a decision or to make a selection. It's therefore a structure which is composed of an if structure inside another if structure, either under the true part or the else part of the latter structure. Nesting is having a structure containing other structures of the same type. If statements embedded one within another are said to be nested. When this structure is being executed, the first condition is evaluated, and if it results to true, then the first instruction under it is evaluated, and the rest of the conditions are not tested, or the rest of the conditions are not tested. Otherwise, if it evaluates to false, the second condition is tested. If it evaluates to true, then the second instruction is evaluated and the process continues. The following is therefore the general format or syntax for this structure. both in Pascal and in C. So in Pascal, we have if condition 1, then execute instruction 1. And my dear students and the rest of the learners, remember, what I'm calling instruction 1 can be a compound statement. So it can be a set of several statements. Else, if condition 2 is met, then execute instruction 2, or the set of instructions or statements that I'm calling instruction 2. Else, if condition 3 is met, execute instruction 3. Else, in other words, if none of those conditions are met, execute instruction 4. And you end each of the instructions or set of instructions, each of the condition has to be ended with end if. Each of the conditions end if. So this end if is ending condition 3. This other one is ending condition 2. And this one is ending condition 1. So every condition should be ended. In C, we use braces to do that. So we write the same in C as follows. For condition 1, if condition 1, execute instruction 1. Else, if condition 2, execute instruction 2. Else, if condition 3, execute instruction 3. Else, execute instruction 4. And end the program. So for C, we end each condition immediately using the braces. As you can see, my dear students and the rest of the learners, for condition 1, we have the right brace or the left brace, and at the end of instruction 1, at the end of that instruction, that statement, we have the right brace. Else, if condition 2, we have opening brace, and at the end of the instruction 2, we have the right brace or the closing brace. At the beginning of condition 3, after checking condition 3, we have the left brace for that condition, and at the end of instruction 3, we have the right brace or the closing brace for ending that condition. For the else part, we have that opening brace there, that is the left brace, and at the end of instruction 4, we have the right brace for ending that instruction, and we end the program. Now, the flowchart for both is as follows. If condition 1 evaluates to true, execute instruction 1. Else, if it evaluates to no, execute condition 2. Or move on and check condition 2. If condition 2 evaluates to true, to yes, execute instruction 2. Otherwise, if it evaluates to false, check condition 3. If condition 3 evaluates to true, to yes, execute instruction 3. Otherwise, if condition 3 is not met or it evaluates to false, execute instruction 4. I repeat, if condition 1 is true, execute instruction 1 and end the execution. Otherwise, if condition 1 evaluates to false, check condition 2. If condition 2 evaluates to true, execute instruction 2 and exit or end that portion of the check. Otherwise, if condition 2 evaluates to false, check condition 3. If condition 3 executes or evaluates to true, to yes, execute instruction 3 and end that part of the program. Otherwise, if condition 3 evaluates to false, meaning nothing has been met or that condition has not been met, execute instruction 4. So instruction 4 will only be executed if none of the conditions evaluates to true. Neither condition 1, nor condition 2, nor condition 3. And we end that part. So that's how we illustrate the nested if using a flow chart. Let's now look at what I have already said. If the first condition is not met, the second condition is checked. If the first and second conditions are not met, the third condition is checked, and so on. Once a certain condition is met, its instructions are executed. So the following is an example of a nested if selection control structure using a pseudocode, a flowchart, and a sample program in Pascal programming language, and I'll also demonstrate another one in C. So my pseudocode, the flowchart, and the sample programs will be based on the following example. Develop a program that accepts radius. Then if the radius is less than 5, it calculates the perimeter and displays the perimeter on the screen. Otherwise, if the radius is between 5 and 10 centimeters, it is greater than 5 centimeters, but less than 10 or equals to 10, then the program calculates the area and displays it on the screen. Otherwise, if the radius is more than 10, it is greater than 10, but less than 15, it will calculate both area and perimeter and display the area and perimeter on the screen. Otherwise, the program displays the message, the circle is too big and the calculation can't be done. So how is that pseudocode written? So the pseudocode begins. Set pi to 3.143. Right. Enter the radius of the circle. Read radius. If radius is less than 5, then calculate perimeter by multiplying the value entered as radius to the value for pi times 2. Display the perimeter. Otherwise, or else, if radius is greater than or equals to 5 and it is less than or equals to 10, then calculate area by multiplying pi times radius, and you write or display the area. Otherwise, if radius is less than 10 and if radius is greater than 10 and it is less than 15, if it is greater than 10 and less than 15, then calculate the area by multiplying pi times radius, and also calculate the perimeter by multiplying 2 times pi times radius. Then display the area and the perimeter. Otherwise, if none of those conditions are met, then write this circle is too big and the calculation can't be done. Meaning, if the value entered is more than 15, or is 15 and above, then our program will not calculate anything. It will just display the message, this circle is too big and the calculation can't be done. And whichever route is taken, the program will stop or will end computing either area or perimeter. So as usual, we end each part. Every else or every if is ended with end if. So this end if ends the condition if radius is greater than 10 and radius is less than 15. Then this other one ends the section for the condition if radius is greater than or equals to 5 and radius is less than or equals to 10. And then this one ends the condition if radius is less than 5. So end if. And we end our program. So that's our pseudocode. Let's look at the flowchart. The flowchart is just as I have explained. Start, then set pi to 3.143. Input radius. If radius is less than 5, if the value of radius or the value entered as radius is less than 5, meaning the condition is true, calculate perimeter by multiplying 2 times pi times radius and display the perimeter. Otherwise, if radius is not less than 5, check if radius is greater than or equals to 5, but it is less than or equals to 10. So, is radius greater than 5, greater than or equals to 5, and less than or equals to 10? If that is true, that means condition is yes, calculate the area by multiplying pi times radius, and display the area. Otherwise, if the radius is not less than 5, it is neither equals to 5 and it is neither less than or equals to 10, then check whether the radius or the value entered as radius is greater than 10 and is less than 15. So, if the value entered as radius is greater than 10 and less than 15, is greater than 10 and less than 15, calculate the area by multiplying the content of pi times radius, and assign the value to area, or calculate area and calculate perimeter by multiplying 2 times pi times radius. Display the value for area and the value for perimeter, or display the area and perimeter. Output area and perimeter. And end the execution. But if the value entered is neither less than 5, nor is it greater than or equals to 5 and less than or equals to 10, and it is neither greater than or equals to 10, nor is it less than or equals to 15, or nor is it less than 15, then that means that what has been entered is more or equal to 15. Therefore, display the message. This circle is too big and the calculation can't be done. My dear students and the rest of the learners, just as I have said, whichever condition evaluates to true, an action will be taken and no other condition will be checked. But if the first condition is not met, the second condition is checked. If the first condition is not met, the second condition is not met, then the third condition is checked. If that condition is not met also, an action will be taken to display that message. So in whatever circumstance, a certain condition has to evaluate to true for an action to be taken. Otherwise, an action will be taken, for example, one which displays a message like the circle is too big and the calculation can't be done. So here is a sample program in Pascal. Calculates either area and or perimeter based on the size of the radius entered. So my program is called area per. We declare memory location for pi to hold a value which will not be changing, which as a fractional part, and we assign that memory location 3.142. Then we declare 3 memory locations which will be holding data that will be changing. That is area, radius, and perimeter. And the data to be stored in it will be of type real. It will have a fractional part. And then we begin, right line, enter the radius of the circle. This message will be displayed on the screen. The user will type radius or a value. That value will be stored in memory location called radius. It will be rand, and the value will be stored in memory location called radius, the variable called radius. Then the compiler or processor will check if the value entered is less than 5. So if the content of memory location called radius is less than 5, then do the following. Begin, calculate perimeter. Pick the content of memory location called radius, multiply by the content of the memory location called pi, multiply by 2. The overall result, assign them in the memory location called perimeter. Then display the perimeter of this circle is. Pick what the memory location called perimeter, format it into 5 characters, with 2 of them being reserved for the fractional part. For example, the perimeter of this circle is 200 or 50.23. And the execution based on the condition that has evaluated true. Otherwise, else if the content of memory location called radius is greater than or equals to 5 and it is less than or equals to 10, then compute area as follows. Then display the statement. The area of this circle is. So display the value stored in memory location called the area. After that statement, display the content of memory location called the area, but formatted into 6 characters, with the 2 of them being reserved for the fractional part. And add execution of that condition. Otherwise, or else if the value of memory location called radius is greater than 10 and it is less than 15, then do the following. Compute area as follows. Compute perimeter as follows. Then display the area, followed by the ones the area of this circle is. Pick what is the memory location called the area, format it into 6 characters, the 2 of them being reserved for the fractional part. That means the decimal point or the decimal point, the characters following the decimal point should not exceed 2 digits. Then, and the perimeter is, pick what's the memory location called perimeter, display it on the screen, formatted into 5 characters with 2 digits representing the fractional part. Then end that condition. Otherwise, if none of those conditions evaluates to true, just display the statement, this statement on the screen, and drop 1 line. The circle is too big and the calculation can't be done. My dear students and the rest of the learners, look at the word can't. Because the single quote indicates that what has been enclosed in between the opening quote and that quote is a character, but in this case, we want to represent that character called the quote, the quotation mark, a single quote, because we want that single quote to be displayed on the screen like can't. Can, we have a quotation mark and T. We add another quotation mark. So the 2 quotation marks there are to help the compiler know that what is there is a character. That what is there is a character. So that's how we write it, and then we end the program. What about in C? This program calculates either area and or perimeter based on the radius entered. We have the pre-processing directive studio, that is standard input-output header file. We have our main as usual. We have our brace there. We declare and initialize our variable or our constant memory location. Const double pi equals 3.142. Then we declare three variables: area, radius, and perimeter. We request the user to enter the radius. The user keys in the value. That value is picked and stored in memory location called radius, which is holding data of type double. Then we check if radius is less than 5. If yes, compute perimeter as follows. Then print the message or display the perimeter as follows. The perimeter of this circle is, pick what's the memory location called perimeter, which is which is of type double, formatted into 5 characters, with 2 of them being reserved before the fractional part. Else, if radius is greater than or equals to 5 and it is less than or equals to 10, calculate area as follows. Display the area of this circle is, pick what's the memory location called the area, display it on the screen, but formatted into 6 characters, 2 of them being reserved for the fractional part. Otherwise, if radius is greater than 10 and it is less than 15, display the message or do the following calculations. Calculate area by multiplying the content of radius by itself times pi, the answer assigned it in memory location called area. Then calculate perimeter. Pick the content of memory location called radius, multiply with the content of memory location called pi, multiply by 2, assign the result the memory location called perimeter. Then display the area of this circle is, pick what's the memory location called area, display it on the screen, formatted into 6 characters, 2 of them being reserved for the decimal point. Then perimeter. Display, or then pick the content of memory location called perimeter and display it on the screen. So, and the perimeter is, pick what's the content of memory location called perimeter and format it into 5 characters, with 2 of them being reserved for the fractional part. My dear students and the rest of the learners, I want you to check this statement here. This statement is a statement of its own. In fact, this statement is not being displayed. If you check on the screen, from here, this is statement for displaying the content. Up to this part, this semicolon, this semicolon here indicates the end of the statement. Remember, every statement in Pascal or in C is terminated using a semicolon. And therefore, the statement which is being displayed is from printf. The area of this circle is area. So that's what is being displayed. This part here is doing the computation. In fact, it is just a repeat of this statement here. So it will not be displayed on the screen. Perimeter equals 2 times pi times radius. It is not part of the statement for displaying on the screen. So let's not confuse the two. I have just placed it at this point. I have just placed it at this point to show you that when we terminate a statement using a semicolon, the compiler treats that line as an instruction on its own. And therefore, even if such a statement as this one follows the printf, If it is not part of the primitive function and there's a semicolon preceding that statement, then that statement is treated as a statement of its own, and therefore, in this case, it is functioning just as this statement here. So let's not confuse that when it comes to writing of output statements. Good. So after we have displayed the area and the perimeter, we also check else printf. In other words, once we have been able to evaluate first condition, second condition, and third condition, and none of them are evaluated to true, then this statement will be displayed on the screen. And once it is displayed, the cursor will be dropped one line below this statement. So you see it blinking below. This circle is too big and the calculation can't be done because of the escape character N in that statement. And we end our program. Let's look at the case structure. This structure is referred to as a switch statement in C. It is used to perform multiple selections, that is, making a decision as to which decision to take from the several options available. It's therefore an alternative structure to the nested if, which is used in a situation whereby there are many options to choose from based on the condition that has been met. In other words, the case works almost the same as the nested if, but it's a simplified version of the nested if. The switch statement consists of a series of case labels, an optional default case, and the statements to execute for each case. The keyword switch or case is usually followed by the variable name or expression called the controlling expression. This is because its value is compared with each of the case labels. If a match occurs, the statements for that case are executed. Then the switch or case statement is exited immediately with the break statement. That is, break in C or end in Pascal. The break statements cause program control to continue with the first statement after the switch or case statement. The break in C or end in Pascal statement is used because the cases in a switch or case would otherwise run together. If break is not used in C or end used in Pascal, anywhere in a switch or a case statement, then each time a match occurs in the statement, the statements for all the remaining cases will be executed. If no match occurs, the default case in a switch or the else case in Pascal is executed that displays an error message. Each case can have one or more actions. The flowchart and general logic of switch is similar to that of nested if. For that reason, we are not going to redraw the flowchart for the case or switch because the one for nested if applies. So the selection is based upon the current value of an expression, which can only be expressed using integers and alphabetic characters only, and is called a selector. So when we are using a case or switch, we have a value that we call a selector, which determines which route or which option will be executed. This means that the value generated from an expression to be used in the selection of an option while using case or switch must be rounded if it's a real number so that it becomes an integer. In Pascal, we use round function to convert a real value to an integer so that we can use it as our selector, while we make use of ceil or float functions found in math.h file in C to perform the same task. So that means if you are going to use switch in C, we must have the preprocessor directive called math.h being included in our program. If using miniscore to determine grade, use case or switch, round the mean score to convert it to integer as follows. In Pascal, we do mean as round whatever you have as mean score, what was float. So round it by using the function round and assign what you get into the variable called mean. In other words, this function is converting the real data type to an integer. So mean in this case will be an integer, while the mean score is a float or is a real. But in C, we do the same using the function ceil to round off or flow. So the two can be used. If a character is used as a selector instead of an integer, it should be represented as a character constant. A character constant is represented as the specific character in single quotes. For example, A in quotes, single quotes. This control structure is referred to or is preferred to nested if in order to reduce the many lines of code. The following is the general format or syntax for this structure in Pascal and in C. So in Pascal, we write it as case expression of label 1, begin, we execute statement 1, we end. If statement 1 is not, if the first case is not evaluated, or if case number 1 does not evaluate true, we move on to evaluating case 2. So label 2, begin, execute that statement. And if label 1 or if case 1 and the case 2 are not true, or none of them evaluates to true, move to case 3. Do what is there if the expression evaluates to true. Otherwise, continue with as many cases as possible. Check all the other cases. Check condition 4, condition 5, condition 6, etc. up to the last condition. So if the last condition is, for example, condition 9, label n, move on to label n or condition 9 and execute what is there. Otherwise, if none of those conditions evaluate true, just execute that statement or a statement and end the case. For switch, we do it the same. Switch, we have the expression, and then the difference. Look at the difference, my dear students, and the rest of the learners. Here we have case label 1. Statement 1, then break instead of end. So in Pascal, you just wrote case expression of. In C, we write switch expression. We don't say of. We use that left brace there. And then for each case, we write case label. If it evaluates to 1, we execute the statements there, and then we break. So we use the reserved one to break. We do the same, case label 2. So if case 2 evaluates to true, we execute statement 2, we break. If the condition evaluates to case 3 or to 3, it evaluates to 3, we move to case label 3, execute statement 3, and we break. And that continues up to the 9th or the last condition to be tested. So which is, for example, case label n. So case label n. So if case evaluates to true, if case label n evaluates to true, we execute statement n, we break. Otherwise, if none of the cases evaluates to true, we just display the default statement or an automatic message. So the last statement in switch is default. Default is a reserved one. And then a statement to be displayed or something to be done if none of the cases evaluates to true. and we end our switch. Let's see how we do it in Pascal and C in terms of programs. So a Pascal program for calculating the area and perimeter based on the size of radius entered. This program is similar to what we had in the nested if. The only difference is that now we are making use of case in Pascal. But my program name is case circle, case sac. Declare the constant pi, initialize it with 3.142. We declare our variables, perimeter, radius, and area of type real. We also now declare a variable called radii, which is an integer, so that when we round our area or we round our perimeter, for the sake of using in the case, we round it and we store that value in radii as a whole number. Remember, case can only work, or switch can only work with an integer, a whole number, or a character, constant character. So we begin, enter the radius of the circle, the user enters radius, the value entered is not the memory location called radius. And then we round that radius, we convert the value entered to an integer, and the value gotten is not the memory location called radii. And then now we use the value now in the memory called radii. So case radii of. So what we are calling case expression of, my dear students and the rest of the learners, this is the expression that we are talking about. This expression here. This expression. So you can have this one directly and a case this part called radii here. You can have that expression there, but it is always undivisible. You have that expression as a separate statement, like the way I've done here, so that the value generated is automatically used within your case statement. So case, the value of the content in the memory location called radii of, if the value in radii is ranging in between 0 to 4. For example, if it evaluates to 1, then execute the first case. So compute perimeter, display perimeter as follows, and then you end, you terminate the execution of the either perimeter or the area. Otherwise, if that case, if that expression evaluates to a figure which is in between 5 and 10, for example, 6 or 7 or 8 or 9 or 10, then calculate the area and display the area as follows. So if, for example, this case here, if this expression evaluates to 7, and that 7 is stored in the memory location called radii, then when it comes to case, the first condition will not be true. The first case will not be true because a case 7 of 0 to 4, 7 is not within 0 and 4. So the next case, so that part will be skipped. The whole of this part will be skipped. And then the next condition will be checked. Is the value of radii in between 5 and 10? Yes, 7 is in between 5 and 10. So these statements here will be executed. The processor will compute the area and display the area and end. Otherwise, if that expression of ours evaluated to a figure which is between 11 and 14, for example, it evaluates to 13, then is 13 in between 11 and 14? Yes. So this condition will be true. And therefore, the processor will compute the area, the perimeter, and store the area and the perimeter, and also display the message on the screen. It will display area as follows. It will display perimeter as follows, and end. Otherwise, if the value in radii is beyond 14, maybe it is 15, or any other figure, this message will then be displayed. None of those other cases will be executed. So it will move directly and display this statement. This circle is too big and the calculation can't be done. And that part of the program will end and the program will end. What about in C? How do you do it in C? So that is the comment. We include the preprocessor directive s3.h. We also include a preprocessor directive called for a file called math that contains functions for computations or for mathematics, functions that we want to call to perform certain computations or evaluate certain expressions. We are doing this because of conversion of the float to an integer. So we then have our main function. We declare memory location for a constant value, which will be a decimal number or a number with a decimal point or fraction, and it's called the pi. We initialize it with 3.142. We then declare three memory variables or three memory locations whose content will be changing. That is perimeter, area, and radius of type double. That means a number with a fractional part. Then we also declare a variable for holding a whole number. When we round the radius entered, it becomes an integer. That integer will be stored in the memory location called radii. So radii is for holding the rounded value, the rounded figure, so that we're able to use it in the switch. Then we display the message, enter the radius of the circle, and we drop one line on the screen. So the user will enter the radius below that statement on the screen. After pressing enter, that value will be picked by the processor, store it in the memory location called radius, which is of type double. And then that value entered in the memory location called radius will be picked by the processor, and the processor will round it using the function called flow. Flow is found in the preprocessor directive for months called math.h, that header file called month. That figure will be rounded using flow, and it will be stored in the memory location called radii. So that value now will be used in our switch. So switch, radii, switch. What is the content of the value of radii? So if the content of the memory location called radii evaluates to either 0, 1, 2, 3, or 4, then calculate the perimeter by multiplying 2 times pi times radius and display the perimeter on the screen as follows. My dear students and the rest of the learners, kindly note how we are writing case in Pascal and here. Here, instead of writing level 1, level 2, level 3, we are using case 0. That's a range of cases. So if this program or this expression evaluates to case 0, case 1, case 2, case 3, or case 4, that means 0 to 4. We don't write it as case 0 colon 4. No, we write them as separate. Case 0 colon, case 1 colon, case 2 colon, case 3 colon, case 4. So if our expression evaluates or generates any of those values, 0, 1, 2, 3, or 4, our program will execute perimeter and display the perimeter. And then we end the execution or the checks. Otherwise, if the content in memory location called radii evaluates to 5, 6, 7, 8, 9, or 10, meaning case 5, case 6, case 7, case 8, case 9, or case 10, if any of those cases are correct, if the value that we have been able to generate from the expression, from this expression for rounding, this expression here, if the value generated here is, for example, 7, if after you have entered a radius, and that radius after rounding it generated, for example, 8, and that 8 is stored in memory location called radii, then under switch, we have switch 8. That means the compiler or processor will skip case 0, 1, 2, 3, 4, because radii contains 8. So it will move on to the section where 8 is scattered 4. So case 5, no. Case 6, no. Case 7, no. Case 8, yes. Case 9, no. Case 10, no. But because it is evaluated to 8, so we execute what is under that case. So if the value in radii is either 5, 6, 7, 8, 9, or 10, the compiler or the processor will compute the area and display the area on the screen as follows and end the execution or move on to the next statement after the switch. Otherwise, if radii generated another figure like 11, 12, 13, or 14, then we compute area, we compute perimeter. The processor will display the area and the perimeter on the screen as follows. Remember, just as I said in the other presentation, we don't need this part there. So this part, don't bother including it in your program because it is a repeat. It's not indicated before here. I said I'm only using it in my demonstration to illustrate to you that when you are writing your code, you may place some statements somewhere which may be redundant. So this is not part of primitive. It's not part of the statement which is being displayed because the display or the output statement is up to there. So this is what will be displayed on the screen. Otherwise, this is an execution or a processing statement, which is just a repeat of what is here. So this statement is correct, yes, but it will not be part of those which will be being displayed. And then once that is done, we move on to default. If none of the cases evaluates to true, none of the conditions are met, then automatically the program will display this message. This circle is too big and the calculation can't be done. And that will become the end of switch or the end of our program 2. And with that, my dear students and the rest of the learners, we have come to the end of section 2 in this presentation, in which we have looked at the selection control structure. You can now continue to section 3 of 3 in this topic on control structures, where we are going to address or discuss on the iterative control structures. That is in part 17 in this series of presentations or tutorials. Therefore, congratulations for learning section 2 of 3 of the topic control structures. You can also access section 1 and 3 of this topic, other topics in computer structure and programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to this channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me, and God bless.